Welcome to Ask and Learn.
We're given a deterministic finite-state automaton. We are asked to find the language recognized by this automaton. The automaton can be found in exercise 22 of this section. So, looking at the figure, we see that it contains 4 states. 6 states, S0, S1, S2, S3, S4, and S5. So I'll draw a table. On the left side, I'll have the states, and in the right column, I'll have the inputs, which can only be 0 or 1. So for the states, we have S0, S1, S2, S3, S4, and S5. Now the way this table works is, if there's an arrow from a state Si to a state Sj with a label X, then I'll write down Sj in the row Si and in the column X of this table. So for example, there is an arrow from S0 to itself with a label of 0. So I'm going to write S0 in the row S0 under the column 0. And likewise, I can fill in the rest of the table. Now we see that S0 is marked as the start state. We also see that states S0, S1, and S5 are all circled twice. So these are the final states. So a string is going to be recognized by the automaton if we end at state S0 or S1 or S5. Okay, so for the first case, let's suppose that string is empty. Called lambda. Then it follows that we're going to remain at S0. Since S0 is a final state, this means that lambda is one of the strings recognized by the automaton. Now, also notice that at S0, if the string contains only zeros, then we'll also remain at S0. So let's suppose actually the string is lambda or contains only zeros. Then we're going to remain at S0, and it follows that 0 star is a subset of the recognized language. This includes lambda as one of its strings. Okay, now the question is, how are we going to end up at the final state S1? Well, suppose the string contains only a 1. then we're going to move from S0 to S1, and so it follows that 1 is one of the recognized strings. Of course, we could also have only a 1 or any sequence of zeros followed by a 1. So if you have any sequence of zeros, then we'll remain at S0, and then the 1 will move us from S0 to S1. So it follows that 0 star 1 is also a subset of the recognized language. And we see that the reason that we only have a 1 at the end is because if there are more bits, then no matter what, we can't return to S1. Now, let's think about how we can end up at state S5. So let's suppose the string contains, first of all, any number of zeros, including no zeros, followed by, to get to S5, a 1, so if we have a 1, then this means we're going to move from S0 to S1, and then suppose the remaining string has 0 as the next bit, then we're going to move from S1 to S3, and now suppose that the next bit is a 0, then we're going to move it from S3 to S5. And then finally, let's suppose that the remaining string has any number of 1s, including no 1s. Then we're going to remain at S5, which is a final state. And so it follows that strings in this set 0 star 1 0 0 1 star. This is going to be a subset of recognized language, and this can be rewritten as 0 star 1 0 0 1 star course, that was only one way to get to S5. So then, let's also suppose that the string contains any number of zeros. Followed by a 1 again. And this time, instead of being followed by a 0, followed by a 1, and we're going to move instead of moving from S3 to S5, we're going to move from S3 to S4. Well, no, that isn't right. Sorry. Instead of moving from S1 to S3, we're moving from S1 to S2. Okay, so we're at S2, and now we want to avoid going to S4, so let's suppose that the next bit is a 1. Then we're going to move from S2 to S3. And then, again, we want to avoid S4, so let's suppose the next bit is a 0. And we're going to move from S3 to S5. And of course, at S5, if the remaining string has any number of 1s, then we're going to remain at S5. And this is a final state, so this is going to be recognized by the automaton. So all strings contained in the set 0 star 1 1 1 0 1 star which can be abbreviated as 0 star 1 1 1 0 1 star is a subset of the recognized language. So now we've covered all the cases, and so it follows that the language generated by the automaton is the union of all these sets. And so we have 0 star union with 0 star 1 union with 0 star 1 0 0 1 star union with 0 star 1 1 1 0 1 star And we see this can be combined into 0 star union with 0 star 1 union with 0 star 1 0 0 comma 1 1 1 0 1 star. And this is our answer.